Are we recording? All right, this episode's going to be hot. Hey ALD Stories listeners, Tyler here. This month's episode is a really special one and one I'm really quite excited about. As we are all aware, anthropogenic climate change is one of the major global issues facing the human race this century. The Earth is getting warmer, and we're consistently seeing the consequences of this in the form of increased natural disasters, rising sea levels, and the destruction of ecosystems. We are learning and innovating in new ways to attempt to mitigate climate change with the advent of renewable energies, electric vehicles, and much, much more. But what about the industries that are used to make these technologies? CVD and ALD equipment comprise an enormous $14 billion industry dominated by the semiconductor manufacturing and electronics markets. Markets where rapid innovation to decrease feature size begets a rapid growth in emissions and energy use. How green really are the fabs that are used to create chips, batteries, and solar cells? Are the processes sustainable, or is the irony that the same methods to produce these planet-saving technologies cannibalize their benefit? Some researchers are beginning to ask this question. In this episode, I sit down with professors Henrik Pedersen from Linköping University in Sweden, Jonas Sundqvist from Bald Engineering, and Sean Berry from Carleton University in Canada. Recently, the three of them published a paper titled Green CVD, Toward a Sustainable Philosophy for Thin Film Deposition by Chemical Vapor Deposition, where they provide perspective on the sustainability of current CVD methods and offer some ideas for a future direction of research to impart greener practices in thin film deposition. We talk on topics including the current state of CVD in the context of sustainability, clever ways to design ALD reactors, atom economy of precursors and processes, and how we can begin moving towards a green CVD philosophy as a collective. I can't thank Henrik, Sean, and Jonas enough for starting this dialogue in the thin film community and for their time in recording this episode with me. I encourage everybody listening to take a look at the paper, which I have linked down below. Please leave your thoughts and comments, share this video around, and continue to keep the conversation going about sustainability in the field. So with that, grab your tea or coffee, sit back and relax, and please enjoy episode 7 of the ALD Stories podcast.
Welcome to ALD Stories, a series of conversations where we share the untold stories of atomic layer deposition and the people behind the technology. This podcast is brought to you by Metalloganic, the home of ALD.
Okay, great. Well, yeah, as I mentioned, was really excited to see the paper get published and read through it, and just that this conversation on sustainability in the field is something that's getting started. And so I just wanted to first ask, how the three of you got chatting about this topic, how the conversation was sparked, and how you ended up together working on this project.
I started having these thoughts around how sustainable is really CVD, the way we're doing it. And I mean CVD in the broad aspect, also including ALD. I've had that on and off for years now, but it was last Christmas break when I started to formalize them in some sort of text. And then I started talking with Jonas about it, because Jonas and Sean, they are my two go-to guys for discussions on various topics. So I started talking to them about it, and we started building the ideas more and more clearly together.
Yeah, and I would say that I was the third one in on this. Jonas and Henrik had put together really the foundational work. And then I guess they called me in to get a more of a precursor perspective. And so I brought in a bunch of the examples that kind of our group and other groups have done to kind of demonstrate how a principle might be applied. And so, so I would say it was definitely Henrik's initiative for sure. And then Jonas brought in the industrial perspective, which is obviously a very important part of this. And then I just drew a couple of pictures.
So I've been doing, since I'm doing as an analyst for TechSet, so since more than 5 years, I'm keeping track of the amount of CVD precursors and ALD precursors that the planet is using now and historically, and forecasting like 5 years out. And after Sean came along, then out of nowhere came a paper from IMEC. It was looking at logic wafers. So basically all those wafers that goes to our iPhones, Samsung Galaxies and so on, for the processor, for laptops, for servers. And with that data, it was also again possible to just add the energy aspect to this manufacturing in the semiconductor industry. So it's also going up, and in this case, it's more closer to like exponential growth.
Now, as you started working on this paper, and maybe even before, did you feel there was any conversation about sustainability in the field happening? Was there anybody who felt like that was taking it seriously, or maybe working towards something at that point, or are we really starting from square one right now with this philosophy?
If you define sustainability in the way that it should be more safe for the people involved in the process, there has been some work on less pyrophoric alternatives to TMA, or trimetal aluminum. That's for sure. If you define sustainability from the point of view that it should be better for the planet, I would say no. If you do not count the various attempts to lower process temperature by adding plasmas. But that has not really been focused on reduce energy consumption rather than to reduce the substrate temperature.
I would say that from a precursor and like atom economy point of view, there has been, at least in academia, some work on moving towards earth abundant elements to kind of, but again, it's to improve supply chain a lot. Like all of these initiatives are also cost saving. And so earth abundant elements to reduce handling and waste and to secure supply chains, that's been done a little bit, but it didn't really have traction in, like there's no sessions in the ALD or any CVD conferences on sustainability.
So that brings up an interesting point about this philosophy in general. There are a number of items, it sounds like, and that you've brought up in the paper that can be addressed in one way or another, are being addressed in one way or another, whether it was in the anticipation of trying to be more sustainable, or for what was just for manufacturing and cost cutting type of initiatives. But it's a very dynamic situation. It's a very dynamic philosophy. And do you have any idea of where you're going to find the kind of synergy between reducing energy, it's making things safer, and where you kind of see the being able to gain the most points for this philosophy while kind of minimizing the downsides of it?
Well, one thing that is very important to point out is that what we suggest as a green CVD philosophy is it's all kinds of research to make CVD more sustainable without decreasing the quality of the film or the quality of the component that you put out from these CVD products. And that is, we realized how extremely important that was to point out during the review process, because one reviewer was really sort of stuck on this, that, okay, you cannot do this because it's going to make the films less good, and all kinds of financial arguments. And we're like, okay, but research is needed to make this and without decreasing the quality. So that is one thing that is really really important. But
yeah, I just want to fill in that we had this example, however you deposit tungsten, some metal nitrides like tinitride, tantalum nitride, you need to clean it out of the chamber. The standard way is to do NF3 remote plasma feed, and NF3 has a huge cross-section for absorbing heat, and is worse than carbon dioxide in the atmosphere for the greenhouse effect. So I mean, this is an issue. The wafer has been processed, the tool bits has already been processed. It's a cleaning process, so it doesn't really directly, maybe it has secondary effects on the product, but it doesn't have a direct effect on the product if you replace NF3 with fluorine, for instance. Fluorine has no thermal cross-section at all. It's not a good gas, then you move the issue to health issue, and you can have an engineering solution how to trap fluorine. But this will go in this, as Sean said, this iterative circles. So there's no like answer like this on this question. It's very complex. Like,
well, and I think one of the targets for the paper isn't that we were offering solutions. I mean, it would be great if we could just solve everything, but it was more to maybe encourage, I hate to say it, right? Younger people, people new to the field, people starting research careers, to think that maybe researching sustainable CVD is a viable way to like define a research program and get involved in CVD and ALD research with the main theme of sustainability. None of the three of us do that. And we've got established research programs and careers, but maybe somebody starting out just would encourage them to do that.
So this idea of almost planting the seed for beginning an entirely new field within the deposition community.
It'd be the ideal. It'd be nice if this became a seminal way in which people thought about ALD and CVD. Hopefully, we'll see more and more kind of writing around the idea of green deposition, particularly green gas handling.
This is part of the reason I wanted to have this conversation with the three of you today too, because I think it's a great initiative, and it's whatever way it can be platformed and can start to get some exposure outside of just the paper being shared around. I'd love to be a part of that. That brings up another point that I was kind of interested in, is, where, and maybe it's a bit of a loaded question in this way, but where do you feel the kind of burden or the onus, who is that lying on for coming up with and really proving a sustainable or green CVD process? Is this something that's needs to start in the research community, or do you see that this could be something that the industry would be interested in beginning to invest in?
Well, I have already some contacts with various CVD industries discussing how to do greener CVD processes. So I know that industry is in fact interested in how can they make their production line with CVD more sustainable. And so I do hope that this could have a good push from industry, but of course academics needs to pull their part as well. And hopefully it can be a new way of collaborating between academia and industry a lot more.
In the semiconductor industry, so one of the bigger CVD companies, and they also do other things, Applied Materials, they have a strategy for green fab. They look at a holistic model of the fab, not only, what ALD tools are in there. They also think about, the software, the system to shuffle wafers around in the fab, and they also look at the supply chain, what's going in and out of the fab. So they have a program I think they call it Green Fab. And there's like companies like downstream of the process chamber, like Edwards Vacuum, famous pump company, now Swedish. Had to mention that. So they also they given talks the past couple of years on these topics like sustainable, what's coming out. They have to take care of what when Sean invents a new copper molecule or gold molecule, it's eventually these guys that are going to pump it out of that system. If it's gold, they're probably going to scrape it off and collect it. But there's pyrophoric. What do you do with the pyrophoric precursors coming out? They are explosive, they're dangerous. There's also the health and safety aspect in sustainability, what Henrik mentioned in the beginning. So there's a lot. We don't see that there's a gathering every year of the CVD industry players talking about this. It's some presentations here and there. There's like actions in social media. You can see it every now and then. It's when you start a topic, you start reading about it. That's when you take notice. So since
it's so, yeah, well, I have some specific things I'd like to get into, but maybe I can add a little bit of context here, and I encourage anybody who's listening to this to definitely read the paper, and I will put the paper on the Green CVD that the three of you wrote up here as well and in the description. But maybe you can just give us some context of where we are right now with CVD? What are the largest contributors to emissions and so forth, or to poor safety in our labs and in CVD, and what you feel are the most important things to mention about where we stand today with CVD and other deposition processes?
Yeah, so I mean, if I just look at the semiconductor industry, so a country like Taiwan that supply the world with semiconductors, you know, Taiwan Semiconductor Company is the world's biggest foundry by large. They also produce memory chips. They, 2019, 5% of their energy produced went into keeping the fabs running. It's 5%, you know, people are canceling flights because they think their 2% of the country's output is killing the planet, you know. Here is the, it's 5% is a considerable amount. Taiwan didn't get the monsoon season this year, and they ran out of water. The fabs in Taiwan are now shipping water to the fabs on trailers, big tankers on the roads. So there's already the semiconductor industry is impacting, you know, they're using more energy because you use more energy with new advanced lithography. And at the same time, they use more water because there's more cleaning process. The need for clean water in fabs is going up.
We talked a lot about energy so far, and that's one aspect. The other aspect is that the amount of molecules that we put in to the CVD or ALD reactor, and how the fraction of those that actually gets into the film is very small. So the most of the molecules that we actually put into the ALD or CVD reactor are just being pumped out. Some of these gases, I mean, take a gas like ammonia, for instance. It's a very simple gas in many ways, used for the group 13 nitrides a lot in CVD, where the CVD process are so poorly tuned that you need to have 1,000 to 1 of nitrogen to gallium, for instance. So that means that 99.9% of all the ammonia that you put in the process is in fact waste. And all that ammonia was made by a very energy expensive Haber-Bosch process. That is a few percent of the world's total energy consumption is just to make ammonia. Most of that go to fertilizer, but if we waste most of it when doing CVD with it, that's not a sustainable way of doing CVD. And the same goes for metal precursors as well. You pump out so much of them.
And it's not just a question of like atom economy, that getting every gallium or getting every nitrogen into the film. It's a question of waste handling, right? Energy goes into waste handling. Energy goes into capture. And so if we're not being atom economical when we do our processes, particularly by CVD, right? Because ALD, maybe there's more ability to tune there than in CVD. Henrik and I have actually looked into the ammonia problem, and it is not simple to solve. But if we aren't trying to improve these, we're really just putting the burden of the environmental problem into the waste stream. That's exactly where it can't be, right? We're just pushing all of our problems down to letting toxic materials into an environment where we either have to reclaim them and spend energy, or let them go and spend environment. And we don't want to do either of those.
So there were a couple, if I remember correctly, a couple of ideas presented in the paper concerning this waste problem, and one of them that's stuck in my mind and I think is digestible in a way is the idea of recycling precursors, recycling gas streams. Do you have any ideas on how this would be implemented practically, or if there are some practices already that utilize this type of idea?
Well, there are some. For ruthenium, there has been reported a little bit of recycling and reclaiming the precursor, but you can also, I mean, in a way, I think you have to rethink largely the reactor concept. So, I mean, take spatial ALD, for instance, where you shuffle your substrate instead between two chambers, each chamber have one precursor. There you have the possibility to actually recirculate those. It's not just one gas stream that goes over your substrate, and then that gas, when it has passed the substrate, is waste. You have a gas that can be circulated in a chamber, and the substrate goes in there every now and then. So that has, to me, a large potential to be more atom economic, if you will.
And one thing about this kind of thinking, right? If you imagine that you have a chamber where one precursor lives and it just circles around and around, and the precursor gets to encounter the different substrates multiple times until it reacts. You could imagine the chamber being built so it can fractionate the impurities out, but keep the precursors in. Precursors are going to be heavier molecules with less volatility. And so there's got to be a fractional distillation design that could help with that, right? And that's first of all, engineering. And secondly, something that isn't really done. So there's a huge open field of potential research there. Can that be done? What would be a good design? And could you do this by making a different shaped chamber that's cooled and heated in a different way? So there's a few fundamental chemical ideas that could be exploited that haven't been yet. And I would be, if I were reviewing a grant application for something like that, I'd be pretty excited by somebody trying to re-engineer a chamber to allow fractional distillation of the volatile byproducts while preserving the concentration or partial pressure of the precursor. That would be super cool.
Yeah, maybe I can ask you, Sean. There's some other strategies concerning the development of new precursors, or kind of warping the CVD chemistry in that way from actual chemical point of view. Do you have any strategies on making the atom economy better or the chemistry better from a precursor design standpoint?
Well, yeah, I mean, that's all we do, right? That's the whole way in which my group operates, is fundamental surface mechanistic chemistry and thermal chemistry to design better precursors. In the paper we wrote, I used the example of gold. We were trying to get gold to react at a higher temperature, gold 3, so that we could get an ALD process from a CVD process. But if you invert that, so we reinvented a ligand, we found all the low-lying thermal decomposition pathways, and we just changed the ligand so those were inaccessible. And the process temperature shot up by 200 degrees. That put us in the realm of being able to do ALD. But if you think of it in the converse, if you take a poorly reacting precursor and you design in some low-lying thermal pathways, you might allow CVD at lower temperatures and lower precursor concentrations in more environmentally good parameters, so that you can deposit film at low temperature with a low precursor load. And if you do it right, maybe your precursor is nice and stable in the gas phase and falls apart when it hits a surface. That would allow it to be recirculated. So the fundamental work in mechanistic chemistry really can change how much energy and how much what the partial pressure of a precursor needs to be in a reactor.
However, there is also the other side of the coin when talking about precursor design, and this was something brought up by Mikko Rittala from Helsinki University. I mean, metalloganic synthesis, when you do precursors, you almost always start from the chloride, from the metal chloride, and then you do various reaction steps to put on the ligands. But if you could use the chloride directly, albeit perhaps at a somewhat higher temperature, that could perhaps be a more sustainable process, because all the energy and waste consumed and generated by the synthesis is then avoided, and you have to do perhaps a little bit higher temperature in your ALD reactor or CVD reactor. So that's another way to look at the sustainability.
There is a success story here. There's we mentioned it earlier. Henrik mentioned it. The TMA molecule has safety concerns. It's gradually more and more cases being replaced with aluminum chloride. I think it's lower cost to do and lower energy cost to do, because it's of electrolysis process. You create aluminum metal, and I think is a win-win. You have a safer and lower energy cost solution, and today there are known ways of doing aluminum oxide with low chloride You can look, and this was the drive for safety mainly, not so much the cost, because TMA is relatively cheap because the solar industry is using it, so they don't like to pay much. So there's a whole supply chain of TMA has brought down the cost.
This brings up something I had been thinking about. We can't talk about absolutes right now of, we're going to make CVD totally zero emissions next week or next month or this year. And that it's, as we've mentioned earlier in this conversation, it's going to be incremental changes, and that is how we'll eventually make progress. We're talking about deposition processes that are used to make devices, things like photovoltaics, things that go into our renewable energy economy. Will these renewable energy strategies, would they be able to kind of offset the emissions that the CVD processes and the deposition processes that are being used to make them emit?
That's a great way to look at it. But you can imagine how poorly equipped somebody with a PhD in chemistry and then a research group with a laboratory that does chemical synthesis or CVD deposition, how poorly equipped they are to do that kind of analysis. Like we need research, we need policy research, we need like statistical data research in the much larger picture. And I think that is also can be fundamentally interesting and can add to the whole field. We don't need maybe a chemist or an engineer. Maybe we need an economist or a policy maker. That would be a very welcome addition to the stable of people worrying about CVD processes.
And I have already started to discuss this kind of things with the people that I didn't know before at my university, who are expert in life cycle analysis and energy systems. So for instance, if you could take the waste heat from a CVD reactor and heat the office next door, then that would be a way to make the CVD process more green, of course. So there are those kind of things that you can build into a CVD factory or fab that is also part of Green CVD.
Ideally, there would need to be some policy changes. There might need to be some research from economists. Have you thought about or been in contact with anybody that's or have some outlook for how we might be able to move towards making this a more comprehensive cross-functional type of project?
Right. Again, I hate to put the burden on everybody that's younger than me, but that's part of my job as an old guy. And it's right. There's an open valence here. There's an open-ended question that you could really make a very broad program of multiple projects out of. I see a lot of promise in that.
Then and maybe I shouldn't have left the lab, is what I'm gathering from this.
The door is always open.
Yes.
I think Steve George would welcome me back if I wanted to go back and do some work for him. That begs the question then, where do we start? If you have some advice there, what is the practical point or points that we could start moving towards this philosophy?
I think we start with what we do, right? If you're making precursors, point out when you're doing it green. If you're developing processes, point out how to improve those. Maybe if we run conferences, have a session on Green CVD and ALD. Maybe encourage the community through kind of strong arming them into listening to the story over and over again.
But what I really feel that we need to really take a big leap in this field is we need a model for how to quantify the level of sustainability on a given CVD process. And then if you change it by something, drop the temperature or replace thermal heat with a plasma or something, how will that make it more or less sustainable? And that kind of model it's a hard thing to do, but that's, I think, where life cycle analysis people needs to be contacted and discussed with. And how do you put a number on the level of sustainability on a given process?
This is the life cycle assessment that you mentioned in the paper, the LCA, correct?
Yes.
Yeah, and what we it's a bit, just to start the ball rolling and then stop playing. It's a bit stupid. So we have discussed also having like topical workshop on these aspects. You can look out for something coming from us three in the future, not a big conference thing, but either a session. We will force ourselves into existing conference. There's a number of those out there, or some topical workshop online format.
There has to be some kind of spark to get it started to begin with, and I'm really happy that the three of you have really pushed to get it started. And speaking of which, how do you feel the reception of the paper has been? How was the process of getting this actually out and into JVSTA? Was it difficult? Did you feel like you were having pushback on it?
Henrik, would you like to handle that?
Yeah, well, we submitted it actually the summer 2020, first time, and it was chopped to pieces by a few reviewers, and we tried to improve it, and then it was chopped even more to pieces by a few reviewers, and the editor had no other option but to say no, sorry. But it was an interesting topic. Do consider all the suggestions, and then please come again. And then we licked our wounds for a while and rethought the manuscript a bit and rewrote it. And then spring 2021, early spring, we resubmitted it to JVSTA because I felt like that should be the place where it should get noticed in the CVD ALD community. But now the editor of JVSTA was very, very nice to us and said that, well, this is a perspective after all, and these are your thoughts. Do consider some of the comments, and yeah, I will most likely accept it if you send in a revised version, which we did. We essentially, what we tried to emphasize even stronger was that this is suggestions for research to improve the sustainability without affecting the quality of the film or the device. And I don't think I can stress that enough after seeing the review of the manuscript. And then it was published in JVSTA, where it has been viewed close to 1,000 times now. So I think it has created some interest. I haven't heard anything more about it. Nobody has really raised any contact me in any way to say that you're an idiot to write such a thing or anything like that, and nothing positive, nothing negative. So I'm not sure how it has been received really, but it has been viewed at least.
Yeah, and I would say the review process really highlighted that people have all sorts of viewpoints on what should be and should not be considered in Green CVD. But I think that also highlighted that within the community, these are expert reviewers. Within the community, we're ready for a conversation or even a dynamic discussion about what this all means. And I think that's good, right? Can we do it? And if we have the appetite to do it, how do we do it? What are our number of approaches? That's, I think, why it needs to move into conference phase.
Yeah, and I mean, of course, the reviewers did put out some very nice thoughts that we hadn't considered. So those are included in the actual published manuscript. So thank you to the reviewers also for taking your time, of course.
I've never been through as thorough a review process as this paper went through. It was dynamic.
Yeah, it was clear that it stirred up some feelings.
It sure did.
So when we got the notice of publication, then I felt, how should we, celebrate this? So that's when I designed the baseball cap.
So the CVD cap.
Yeah. So Henrik has much greater haircut than the insurance is excused, and mine has got lost somehow. I never got mine, so I will have to order a second one. Maybe I take a blue one.
No, so it's a very limited edition of 2 baseball caps.
Yeah.
Well, where will I be able to buy this cap at some point? Where's the online store going to be?
It will be made available. So I have a company that can, but I'm not sure they are producing green yet. So we have ordered on the limited number. So
I mean, this has been a really, really fantastic conversation. I have to thank you, the three of you, again for joining me and talking to me about this, because it's fascinating. It's topical. It's relevant, and it needs to be addressed. It needs to be be chatted about. And where do you find will be best to keep this conversation going and not let it just fall to once a year at the ALD conference, for instance?
Well, I think this series is a good idea in general, but highlighting it in this series is a good starting point, right? And you say once a year at the JVSTA ALD, which is kind of the big family reunion for the deposition community. But if it happens there, it will happen other places, because that conference is really our main indicator of what the big themes of a given year are. And so I think if we move it into that, maybe in Ghent, maybe after Ghent in Bellevue, then that might precipitate it into the other conferences, into MRS or into the AVS General, or even into the selective area conference. So I think if there's a zeitgeist, if there's really a movement forward on this, it can start at AVS ALD, but it doesn't have to end there.
Our models that maybe we develop will be easy to adapt to neighboring field in the industry. So you have cleaning processes, sputter processes, and so on. It's quite a big industry. If we had some numbers on in the paper, and I think that everybody has to look into their field and see what you can do better, and maybe not always benchmark to huge markets.
And I'll invoke Rika Piranen, who I learned the phrase, don't let perfect be the enemy of good from. So if we wait until everything is perfectly green in CVD, we'll never get anywhere. If we make any incremental change, it's better than making no incremental change.
Great. Thank you for the quote from Rika, friend of the podcast. That's for sure. Also, Jonas, welcome back for the second time on the pod. It's good to have you for sure. I'm so happy that we were able to make this work, because I was very excited when I saw the paper, and I just hadn't seen anything like it before coming for our field. And obviously, as a young person, I suppose at the tail end of the millennials is where I fall. It is a very, very important topic and an issue for me. And I'm lucky and privileged I can even have a platform with this company right now to be able to have these conversations and talk about these things and put it out and disseminate it in any way I can. So thank you so much again for joining me today. I can't express my appreciation enough.
Well, thanks for the platform. Really, I'm glad to highlight particularly this bit of work that we've all done, because it's nice to get these ideas out. Hopefully it will engender a discussion.
Yeah, I can only concur. Thank you very much for reaching out to us. It was a very nice initiative from you. Very happy about it.
Same here. So it's great to be here again. And I think this is my last appearance.
So I'm under the handle Scientist Tiger, but if you just look for my name, you can find me there. And of course, at Carleton. So you can find my website pretty easily. And we're recruiting grad students and postdocs right now. So
yeah, you can search for me on Twitter as well. And also Google Henrik Pedersen LIU, and you find my group website and my website on the university.
Okay, yeah, and I have a baseball cap because I'm bald, and I have a blog called Bald Engineering. So it stands for B is blonde, I'm blonde, and ALD is obvious. So,
well, I hope that I'll be able to see all of you at the ALD conference maybe next year. We'll be in Ghent next year. Is that right?
Yep. Led by Christophe de Tavernier.
Yes.
Perfect. Well, I'm looking forward to it, and we'll hopefully see you all next year. And with that, enjoy the rest of your autumn, enjoy the upcoming winter, and keep making strides towards great things.
You're listening to ALD Stories with Benek, the home of ALD. To stay tuned for new episodes, make sure to follow us on Spotify, Google Podcasts, or Apple Podcasts. We hope you enjoyed today's show. Talk to you in the next one.